What's up, it's Carter, and in this video we're going to be talking about catalytic converters and emission systems. The vehicles referenced in this video are a 2017 Buick Encore, a 2006 Toyota Corolla, and a 2023 Chevy Colorado. We started testing on the 2017 Buick Encore. For our testing, what we did was run the car for 15 minutes at idle and then at 2500 and took pre and post cat readings.
Alright, so I got the front inlet measured for the cat. So this is pre-cat. And this is the measurement post-cat.
We started testing on the 2017 Buick Encore. For our testing, what we did was run the car for 15 minutes at idle and then at 2500 and took pre and post cat readings.
Alright, minute number 7. On the upstream we have, let's see here. There we go. 72, 73. Downstream, 150.
For testing on our 2006 Toyota Corolla, we used a scan tool to monitor how discrepancies in air can affect our long and short-term fuel trims.
Alright, so we've added mass airflow sensor, ECT sensor, and then the IAT sensor as well. Do you want to create some unmetered air?
What? Here you can see how we are adding unmetered air into the system to see how this affects our long and short-term fuel trims.
Alright, so we're going to do more unmetered air and we see how those other sensors are affected. Alright, so looks like we've got a lot less airflow coming from the mass airflow sensor. Intake air temperature is also a little higher. ECT's staying around the same. Our O2 sensor voltage staying pretty low, so it's going lean. Our long-term fuel trims are very high. Alright, we have this 2006 Toyota Corolla. We have the PID values for the O2 sensor, bank 1, sensor 2, oxygen sensor voltage, short-term fuel trim, and long-term fuel trim. And we're gonna get it up to operating temp. Okay, here's our readings at operating temperature here. Short-term fuel trim still looks like it's not on bank 1, sensor 2. Looks like it's not operational.
That's how hot our exhaust is right now.
But for the short-term fuel trim, it's around -1, -3. And long-term fuel trim is about 9%.
As you can see from testing on the 2006 Toyota Corolla, once short-term fuel trim stays rich or lean for too long, the long-term fuel trim adjusts and compensates for the short-term fuel trim. Here we have the same scan tool data, but this time we ran the car up to 2500 RPM. You can see how the fuel trims adjust for the engine load. For our last round of testing, we decided to use a scan tool on the 2023 Chevy Colorado. As you can see from the scan tool data, the sensors read according to lambda and give you a reading based off that ratio. You can also see how this vehicle reads long and short-term fuel trims in a similar way to the 2006 Corolla. Once the short-term fuel trim stays at a certain ratio for too long, the long-term adjusts for it.